Serving as the pivotal location of the 1979 film Alien and its 1986 sequel Aliens, LV-426 is a dark and desolate world of jagged rocks and unrelenting winds. Although devoid of any indigenous life, it is the site of a crashed extraterrestrial spacecraft harboring dormant eggs of the deadly alien species that would come to be known as xenomorphs. 35 years after the crew of the starfreighter USCSS Nostromo first discovered the derelict alien craft, a human terraforming and mining colony was established on the planet that, at its peak, maintained a maximum population of 158 residents, until its eventual xenomorph infestation and subsequent destruction 22 years later. The planet, which was named Acheron upon human settlement, is a primordial wet terrestrial with an equatorial radius of approximately 96% that of Earth. It has a reported mean density of 5.075 grams per cubic centimeter and a surface gravity of 0.86 g. These parameters give Acheron a calculated mass of 75% that of Earth and reveal that it possesses a very distorted shape, making it either extremely oblate, with an equatorial radius over 433 kilometers larger than its polar radius, or tidally stretched with a radial elongation of over 220 kilometers. Prior to the construction of an atmospheric processing plant to help terraform the planet and make its environment suitable to human life, the planet's native atmosphere consisted of nitrogen, water vapor, methane, and a toxic mix of volcanic gases such as carbon dioxide and sulfur dioxide. Although numerous geysers and fumaroles can be found in various locations around the planet, it is reported that there does not appear to be any active volcanic or tectonic processes currently altering the surface geology. This is unusual for an object of Acheron's mass and may suggest that it formed in a region of the protoplanetary disk that had a low abundance of super-heavy elements, which would otherwise continually pump heat into the planet's interior through the process of radioactive decay. The first humans to land on the planet reported the surface temperature at well below the freezing point, meaning any water on the surface would likely be locked up in ground ice or blowing through the atmosphere as tiny ice crystals. But soon after the atmospheric processor was brought online, the temperature and pressure were raised significantly to something apparently in excess of 10 degrees Celsius and 90 kilopascals, respectively. This alteration initiated a water cycle and would eventually result in the formation of numerous lakes and seas around the planet. Technically, Acheron is not a planet, but rather a moon, one of three major moons orbiting the gas giant Calpamos. The composition of this Jovian planet is similar to that of Jupiter, yet it is considerably larger, having a reported radius 2.14 times larger than Jupiter and being roughly 10 times as massive. However, this reported size is anomalous. The high gravity of Jovian planets causes the gases in their atmosphere to compress with added mass, increasing in density rather than in radius. Given the mass of Calpamos, it should instead have a radius comparable to that of Jupiter, or perhaps even smaller. Calpamos is sometimes referred to as a protostar or brown dwarf, but its mass and temperature are too low to classify as either of these objects. Acheron is said to orbit Calpamos at an average distance of approximately 1.79 million kilometers, with a period of 5.07 days. However, these parameters are not mathematically consistent with a mass given for Calpamos. Instead, Acheron should have either an average orbital distance of 1.83 million kilometers or an orbital period of 4.89 days. Like virtually all major moons, Acheron is tidally locked with its parent planet, leaving one side perpetually facing the sepia cloud tops of the large gas giant. For an observer on the planet-facing side of Acheron, Calpamos would occupy over 9 degrees of the sky, appearing nearly 19 times larger than Earth's moon. For an observer on the space-facing side of Acheron, Calpamos would never be visible, leading to much darker nights, but a less complicated day-night cycle of approximately 60 hours of light, followed by 60 hours of terrifying darkness.
We better get back, because it'll be dark soon, and they mostly come at night. Mostly.
It has been hypothesized that Acheron did not form around Calpamos, but was instead captured into orbit sometime within the past 40 million years. However, I find this scenario unlikely. First, planetary migration, collisions, and capture events typically only happen within the first 100 million years of a star system, as its planets are forming and settling into place. But the Zeta Reticuli system is at least 3 billion years old. There shouldn't exist any instability in such a mature system that could lead to two planetary orbits intersecting. Secondly, such an event would have severely disrupted the Calpomos system and scattered or destroyed Calpomos's native moons, which does not appear to be the case. Of the three major moons orbiting Calpomos, Acheron is said to be the second, leaving one moon interior to Acheron's orbit and one exterior to it. Given that Acheron does not seem to experience significant levels of tidal heating, we can assume that the distances between each moon's orbit are quite vast, and that the scale of the moons in this establishing shot are greatly exaggerated. Calpomos's innermost moon has been designated LV-426 and was visited by the U.S. CSS Prometheus in the 2012 film of the same name. The film establishes the moon as being a wet terrestrial with an atmosphere and geology comparable to Earth's. This implies the existence of a biosphere on the moon, but it is unclear whether it is native or engineered. The outermost moon, whose designation is never stated, is shown to be a frozen world completely covered in ice, suggesting it possesses a thin primordial atmosphere and cryovolcanic geology. Calpomos is the fourth planet of 8 in the Zeta II Reticuli system and orbits its parent star at a distance of 1.08 astronomical units, with an orbital period of approximately 410 Earth days. Zeta Reticuli is a wide binary system lying 39 light-years from the solar system. Both of its stars are G-type main-sequence yellow dwarfs very similar to our Sun. Zeta 1 Reticuli is a spectral class G4 star of 0.96 solar masses and 0.76 solar luminosity. Its companion, Zeta 2 Reticuli, is a spectral class G2 star of 0.99 solar masses and 0.97 solar luminosity. The two stars orbit one another at a distance of approximately 3,750 astronomical units with an orbital period of over 170,000 years. So how does Acheron LV-426 measure up scientifically? It's wonderful that Acheron has values for its equatorial radius, mean density, and surface gravity, and that all of these values are within a realistic range. That's quite rare for a science fiction planet. However, the only way that these values are mathematically consistent is if the shape of the moon is very distorted. But such a high distortion is difficult to explain. The most obvious cause would seem to be tidal stretching from the gas giant's high gravity, but this doesn't work, as the tidal forces are not strong enough at that distance to significantly distort an object of such a high density. I suspect that the author that penned the parameters for Acheron knew enough about astronomy to place the moon's radius, surface gravity, and mean density within a realistic range, but not enough to know that these parameters, along with the object's mass, are interconnected. And instead of calculating these values, they simply assign them arbitrarily, unaware of how they would affect the moon's structure. 0 stars. The orbital parameters for Acheron are completely wrong, but they are close to being correct. Not close enough for me to give them a pass, but close enough that it's clear that the author that penned Acheron's parameters had a good working knowledge of astronomy, but seemingly lacked the math skills necessary to actually do the calculation and get it right. -1 point. It's hard to say anything about Acheron's climate realism, as its climate is the result of a terraforming effort. Once an author invokes sci-fi technology mumbo-jumbo, the scientific discussion goes out the window. If they had given a value for anything, the nitrogen-oxygen ratio, the atmospheric pressure, even the average temperature, then I would give it the point. But they have basically just left it at breathable. So, 0 points. The parent planet of Acheron, Calpomos, is fairly well built. Its radius is too large, but it has a good mass for a gas giant, even though the author thought they were making it massive enough to be a large brown dwarf and possibly even a near-stellar object. The mass ratio of Calpomos and its major moons is excellent. It could absolutely have moons of the masses depicted, and the number of major moons is quite believable. It would have been good if they had made at least some mention of its minor moons, of which it should have hundreds. But we can always assume that they do exist, but that the author just didn't feel that such objects were worthy of attention. The orbit of Calpomos about its star is accurate enough, and the planet is a realistic color. It is unlikely that it would have ice rings being within the habitable zone, but it's not necessarily impossible. So overall, it gets more right than it gets wrong. Plus 1 point. The Zeta Reticuli system was an excellent choice as the setting for their story. Being a real star system, its parameters are guaranteed to be realistic. And with both stars being spectral type G main sequence Sun-like stars, they really couldn't go wrong. So, plus 1 point. With a total of 1 point, the moon Acheron LV-426 from Alien receives a D grade. Its authors provided a good amount of information and got some things right, but they neglected to do the math and ensure that there was some actual science in their science fiction. Now, following a thorough search of my ship to make sure there are no foreign life forms, I'm setting a course for yet another alien world. I hope I will see you there. This is Lieutenant Aldridge, host of Alien Planetology, signing off.